So we're going to have a quick look at how a capacitor actually works. Now remember, it stores energy, so in that sense it's just like a battery, but generally it either charges up or discharges its energy quite quickly compared to a battery. So we have here a 12-volt battery, and that is going to charge up our capacitor. So this is the capacitor right here. Now, in series with the capacitor in this circuit is a resistor that is our load, and that is this little light globe here. So at the moment, you can see that there's no current flowing. Firstly, there's no light on in the capacitor, but also we have, measuring the voltage across this light globe, we have the crow here, the cathode ray oscilloscope, that's going to show the shape of the voltage that appears across this globe. So at the moment the battery's connected, but there's no current flowing because remember the capacitor that is acting like parallel plates with an insulator in between them won't let any current through. So the only time we're going to see current in this circuit is just for a brief time when we disconnect the battery and instead just have the capacitor in series with the resistor. So when I flick the switch, that's what's going to happen, and you will see how the charge being released from a capacitor would be different from the charge being released just from a little AA battery. So the light globe went on, but not for very long. There was a bright flash and then it faded over about a second or so. That suggests that the time constant, which means the time it takes for this capacitor to discharge about 2/3 of its charge, is maybe a second or so. That depends on the capacitance, also on the resistance of the load that's in the circuit. I'll just flip the switch again, and you can see the shape of the voltage across this light globe. It basically peaks and then it tails off gradually. And that's a typical shape for a capacitor.